Hey guys, I just wanted to go over the solutions to your practice problems with you. These were assigned on Monday. So, in order to attack our practice problems on page 369, we first will need this formula. And it's pretty straightforward. It's just current is equal to charge divided by time. So charge is shown here by delta Q, change in charge, and I've also shown a change in time, which is fine. You can drop the delta if you want, and in some of the problems I work, I will do that, kind of depending on the problem. What is electricity? It's kind of a fundamental question. It's just the flow of electrons, okay? The movement of electrons through a conductor will produce electricity, okay? And current is just the movement of those electrons through a conductor over time. And each electron has a specific charge. So if we know this charge value, we can actually calculate the number of electrons moving through the conductor. And I don't think we need to worry about it in grade 10 physics, but if you move on to DP physics, that will become a little more important. Okay, so first question, very straightforward application of this formula where current is equal to 200 coulombs divided by 65 seconds. That gives us 3.08 amps, and you will note that there are 3 significant figures for that problem. Second problem, same formula, just slightly rearranged. So we multiply both sides of this formula by change in time, and we will get change in charge is equal to current times change in time. So our current is given as 600 amps, and our time is given as 2.48 seconds. So that gives us 1,490 coulombs. Again, 3 significant figures. Okay, next we are asked to find the amount of time required. So we're asked to find how long the battery can deliver a current of 450 milliamps. Okay, so I've done a little bit of a shortcut here. I've converted 450 milliamps directly into amps, but it is important that you do that. So the correct unit here is the ampere. That is our fundamental unit. Okay, so again, I've rearranged my equation so that now time is equal to charge divided by current. So that is what we have here. And I've also done a conversion here. The answer in the book is given by 2.4 times 10 to the 4 seconds, but that is quite a few seconds, so I converted it to hours just for funsies, and it's about 6.7 hours. And let me just do that. Yeah, actually, the answer given in the book, though, is 2.4 times 10 to the 4 seconds. Here again, we'd have 2 significant figures if we're being very picky about that. And why not be very picky? All right, so that does it for our first set of practice problems. And let's now look at our second set from page 372. Only 2 problems here, and they're going to go quite fast. So here we have our potential difference, and potential difference is given by a capital V or delta V. And that V stands for volts, okay? 1 volt is equal to 1 joule divided by 1 coulomb, as you can see here. So potential difference is equal to energy divided by charge. So one way that we can think of this is the amount of energy per unit charge, the amount of energy carried by our electrons as they move through the conductor. Okay, so first question, potential difference of 120 volts is measured across a light bulb. The light bulb is left on for 30 minutes, allowing a charge of 900 coulombs to flow through it. How much energy is converted to light and heat? This is one of those occasions where they give you something that you don't actually need to solve the problem. They give you time. We don't need that because they've given us the charge, and that is all we need. We have the charge, we have the voltage, we can then find energy. Okay, so we take our original equation and we multiply both sides by Q, and that will give us E is equal to change in voltage times charge. Okay, so I then plug in my values, 120 volts and 900 coulombs. And here again, if I want to be very picky, then my answer will be 1 times 10 to the 5 joules to one significant figure. The book gives it as 1.08 times 10 to the 5 joules. Okay, second problem. What is the potential difference across a resistor? Well, we have a charge of 50 coulombs and we have a change in energy. Okay, so again, this time I'm not even showing the variables. We just plug these values into the same equation as we had above. So change in energy divided by charge will give us our potential difference, and it is 20.0 volts to 3 significant figures. Okay, so pretty straightforward practice problems. I'm going to share this sheet with you, and I don't think there's anything. There is one thing I should point out. Okay, most of this is fairly straightforward. If you look at number 11 here, I need to use some conversion factors to get the correct answer. So I convert hours to seconds, as you can see here. And I also convert milliamps to amps. And you should be very familiar with these conversions right now. So my conversion factors are there. 1,000 milliamps equals 1 amp. 3,600 seconds equals 1 hour. You should familiarize yourself with this conversion factor because it comes up a lot. Very common. All right, number 12. We're given a unit in number 12 that you may or may not be familiar with. It is the milliamp hour. Okay, so if we break this down, what we have here is a current, the unit of current, milliamps, and we have a unit of time, hours, and they're basically multiplied by each other. So this is an opportunity to use dimensional analysis where current times time is equal to charge. Okay, and we know that from our previous equation. Okay, so if that is true, then a milliamp hour must be a unit of charge. Okay, so remember, current is equal to, that's charge. Charge is equal to current times time. Okay, so just a slight rearrangement of our original equation. Okay, so that's what we know. And so what we really have to do here is just convert milliamp hours to charge. And the 9 volts is actually, again, not really needed. They just give us information that we don't need. And this happens pretty regularly in physics, and the idea is definitely to throw you off. They are trying to mess with you. Okay, so here again we use some conversion factors. 1,000 milliamps is equal to 1 amp, so there's one conversion factor applied to our value. And 3,600 seconds is equal to 1 hour. Again, we put the unit that we're trying to get rid of in the denominator. Okay, so I don't want milliamps, I want amps, so milliamps go in the denominator. Same thing with hours. I want seconds. Okay, then I will have the units required for charge, amps and seconds, and my conversion will produce 2.25 times 10 to the 3 coulombs. Okay, that is just about the only interesting thing occurring on this page, except for number 17. Okay, number 17, in number 17, we have to use a couple of different variables in order to get what we need here, okay? So here we have to combine two equations where charge is equal to current times time and energy is equal to voltage times charge, okay? So they give us three values and neither one of these equations by itself is going to give us the answer we need. So what we have to do is combine them like this. So energy is equal to voltage times charge, which is then equal to voltage times current times time. And now we have everything we need, and we can plug in our values, and we will get 396 joules to three significant figures. Okay, 20 involves a very similar strategy. In fact, it is the same strategy, except here I've broken it into two parts. If you want to do that, if you feel more comfortable with that, then you should do that, and it's no problem. Okay, guys, go through these and let me know if you have any questions or think I've made a mistake, which is entirely possible. I'm going to share this document with you as well, and you can kind of keep track of it as I will be updating it as we move through this unit. Okay. Again, let me know if you have any questions, and have a good day.